We are picking up where we left off yesterday in lesson 7.3. So we are still talking about these logarithms, how logarithms connect with exponential functions. What was our phrase for changing back and forth we learned? Left, right, middle? LRM? Okay. So, we're going to look at a word problem here. In December 2004, an earthquake with a magnitude of 9.3 on the Richter scale hit off the northwest coast of Sumatra. In March of 2005, another earthquake with a magnitude of 8.7 hit again. The formula, my favorite words. The formula. Log of I1 over I2 equals M1 minus M2. Compares the intensity of earthquakes where I is the intensity level and M is the magnitude on the Richter scale. How much more intense was the first earthquake compared to the second? And notice there it says the quotient I1 over I2 compares the intensity. So what they're saying here, when the question says how much more intense was the first earthquake compared to the second earthquake, we're looking for that ratio of I1 over I2. Okay? Now, again, you're provided an equation, yes? Log of I1 divided by I2 equals M1 minus M2. What do we know?
Magnitudes.
Yeah, they provided me some magnitudes. What magnitudes did they provide?
9.3 and 8.7.
Okay. Magnitude 9.3, magnitude 8.7. So let's fill those into our formula. The log of I1 divided by I2 equals M1, which what was the first magnitude? 9.3 minus the second magnitude, 8.7. Cleanup step. 9.3 minus 8.7 is 0.6. So the log of I1 divided by I2 is equal to 0.6. What was our job defined here?
How much more intense?
Yeah, how much more intense were they? Or in other words, we're trying to find what is I1 over I2. What is that ratio equivalent to? Right now I have log of I1 over I2. Left, right, middle. We need to get this out of this form. So we're going to use left, right, middle. What do you need to tell me to use left, right, middle here? Log base of something. When no base is given, it's that invisible 10. Since there was no base provided, we assume 10. So what does my statement become if we're using a left, right, middle? Except drop the log out.
Oh, yeah.
Because we're going from log form to exponential form. So if I'm going from log form to exponential form, left is 10. 10 raised to the right to 0.6 equals the middle. My middle is that fraction I1 over I2. What did I say we were trying to find? I1 over I2, right? I want to know what that ratio is. That's the comparison. So, grab your calculator, and if you would, tell me what is 10 to the 0.6 power? Okay, so all we're doing right here is raising 10 to the 0.6 power. Yeah, Sadie, you probably need to do 0.6 exponent button 10. My calculator is pretty basic. I just need to do 10. My exponent button is my little arrow, caret button. In English, it's a caret, right? 10 to the points. Whoops. 0.6. That's my calculator. So Lily read off 3.98, yada, yada, yada. Okay. What is that approximately? That's about 4. So what that's saying is that the first earthquake was about 4 times as strong as the second earthquake. So I'm going to put it's approximately 4 times as strong. Did you figure out your calculator, Sadie? Yeah. Okay. Huh? You don't like this word log? I'm sorry.
Kind of funny. Log.
But don't use the word log. Use logarithms.
Ooh, I like that.
That's not any better, huh?
It's like a log.
Okay. So, backside. Can you do the next one? As you flip over to the backside, it's compare the intensities of the 2 earthquakes. Leave it open.
A pit stop?
Okay, so notice it's compare the intensities of the 2 earthquakes. So we are using the same formula, yes? If you recall from the front, the log of I1 over I2 is equal to M1 minus M2. What am I filling in this time? 8.0, 6.8. So the log of I1 divided by I2 is 8.0 minus 6.8. 8.0 minus 6.8 is 1.2. So log of I1 divided by I2 is 1.2. Okay, I don't want to know what the log of I1 over I2 is. What do I want to know? Yeah. I just want to know what I1 divided by I2 is. So, in order to get it out of this form, same thing as last problem. Left, right, middle. So left, right, middle says 10 to the 1.2 is equal to I1 divided by I2. So, I1 divided by I2 is whatever 10 to the 1.2 power is. Okay, so you do 10 to the 1.2 power, 15. I have written down 8489 ... If we're going whole numbers again, what is this approximately? 16. So that first earthquake was 16 times as strong as the second earthquake. Okay. Ready to look at some graphs? last 2 lessons, we have spent time graphing our exponential functions. So when they are y equals 2 to the x, or y equals 3 to the x, y equals 5 to the x, whatever it was. Now we're going to spend time graphing y equals log x. When we don't know what a graph looks like, we like to set up an XY chart, right? Now, as you look at A, y equals log base 3 of x. If I say x is 0, 1, 2, can you use your calculator to find that? No, because what do our calculators do? Log base 10. Well, graph A is log base 3, graph B is log base 4. So we need a different plan here, because I need an XY chart, but I can't do just any random log necessarily in my calculator. What? Yep, let's switch it to exponential for us. So, if this is currently y equals log base 3 of x, can you use your left, right, middle to put it in exponential form? What does this become in exponential form? What was it? Okay. 3 to the power of y equals x. Because my sides are flip-flopped, right? So it's 3 to the y over here equals x. If you don't like the way that looks, put the log on the left to do it. Okay. So, XY chart. What do we normally do on an XY chart? Pick some x's, plug them in, yes?
Yeah.
Okay. So we pick x's, we plug them in. What x's do I normally like to pick? -2, -1, 0, 1, 2. Okay, start thinking this through. If I put in -2 for x, what do I have to be able to do here? 3 to what power equals -2? You guys know 3 to what power equals -2? You know what 3 to what power equals -1? Okay. Not easy questions to answer, right? Okay. Let's come up with a different plan.
You know what?
I see where you're going. Okay. Well, but like, if we're doing 3 to some power equals, say, 2, it's some fraction or decimal. We don't have that. Okay? Here's going to be my suggestion. Well, general rule of thumb is pick x's because x's are easier to put in. The way this equation is set up, what's easier to plug in? Y's. Is there anything that says we can't just pick y's? If we pick y's, we're going to get our x's out. Are we still going to get ordered pairs? And that's the whole point. We need ordered pairs. So, instead of making your x's -2, -1, 0, 1, 2, I'm going to make my y's -2, -1, 0, 1, 2. So this is what's different about this problem, is I picked my y's to be -2, -1, 0, 1, 2. And then we're going to use our y's to find our x's. I'm writing notes on here for when you are doing homework, you go back and look and say, how the heck did she do that? That's how I did it. Using my x's to find my y's. So, if I put in -2 for y, what is 3 to the -2? Okay. 3 to the -2 becomes 1 over 3 squared, which is 1/9. Yes? So my ordered pair, instead of being -2 1/9, is 1/9 -2. Put in -1. 3 to the -1. 1 over 3. Put in 0. 3 to the 0. Because anything raised to 0 is 1. 3 to the first. 3. 3 to the second. 9. Okay, that's my suggestion of how to do these graphs. Yes? What? This is, okay, so we'll talk about after we get graphed. This does not look the same as an exponential function. Okay? Log graphs look totally, well, they do look the same as exponential function, but they're facing differently. Yeah, they're directionally different. So go ahead and let's graph these. Where is 1/9 -2? We go what? Right a ninth, so just right barely a smidge and down 2. 1/3 -1. So I'm going to go right a third, which is a teeny bit more than a ninth, down 1. Really hard to draw those things, right? 1 0. Where's 1 0? Right, 1 up or down 0. 3 1. Right, 3 up 1. 9 2. Right, 9 up 2. Okay. Can you visualize what's happening here? This is technically the same as an exponential graph, it's just facing a different direction. In my exponential graphs, I'm not allowed to cross the x-axis. What am I not allowed to cross now? The y-axis. That y-axis is acting as my asymptote. We're not going to ever cross it. Okay? And then we're going, instead of going up to infinity, we're going off to the right. Okay? If you recall, at the beginning of yesterday's lesson when I first started talking about logs, I said logs and exponential functions are inverses. Okay? If they're inverses, they reflect over the diagonal line y equals x. And if I just kind of sketch in, okay, you guys, yeah, that line is y equals x. The idea is the exponential function would normally go along here. And so the idea is, you see how that exponential would reflect over and be this log function. Okay, that's the idea, is that this is a lot like an exponential function, has the same shape, but it just faces a different direction. Okay, and I'm not saying you have to, I'm just trying to show you a relationship there. But yeah, they reflect over that y equals x line. Now, before I go on to the next one, there were technically a little bit of other directions in the up there. Find the intercept and the asymptote, excuse me. What do they mean by intercept? Any thoughts? Okay, so intercepts are where we cross officially the x or y axis. In this case, the only axis I'm crossing is the x-axis. Where do we cross the x-axis at? 1 0. So my intercept is the ordered pair 1 0. It also asks me about asymptote. Okay. Where am I not allowed to cross? The y-axis. Now, I agree with the y-axis. However, what is the name of the equation for y-axis? Okay. So vertical lines are x equals a number. The y-axis then is x equals 0. Again, I wasn't disagreeing with y-axis, but officially when they ask for an asymptote, we need to be able to say the equation name. Okay? Once you get these graphs to exponential form, it's not that it's a challenging thing. Okay? It's still just plugging the numbers in. It's knowing how to do it here that's a little bit different. Ready to try B? Can I zoom back into the graph here? You guys got what you need? Okay. Y equals log base 4 of x. So in order to graph this, I need to change my form. What form is this changing to? Okay. 4 to the y equals x. Set up your XY chart. What do you want to do in that XY chart? Fill in our y values. We're doing that because it's 4 to the y. Okay, since y is in the exponent, that's why I'm picking y's. Okay, have you done the math? Without a calculator? 4 to the negative second. 1 over 4 squared, which is 1/16. 4 to the negative 1. 1 over 4 to the first, which is 1/4. 4 to the 0. Anything raised to the power of 0 is 1. 4 to the first. And 4 to the second. 16. You guys quit answering me. Is this just because you're working on your own? Oh no, everyone just quit answering me. Okay. Have you graphed it? 1/16 negative 2. So we're doing what? You're just barely going off of that x-axis and down 2. Excuse me, barely off of that y-axis and down 2. 1/4 negative 1. Again, barely over, down 1. 1, 0. Right 1 up or down 0. 4, 1. Right 4 up 1. And 16, 2. Well. I'm going to go with it's about there. When you draw your graph, make sure you do not cross that asymptote. So do not cross the y-axis. What would my intercept be? Did it change? No. What would my asymptote be? X equals 0. Did it change? Okay. Realizing this graph is pretty much the same. Okay. It's just slightly different stretch to it. Okay. It's stretched out a little bit more. So it goes up a little steeper or out a little steeper does not make sense. I don't know how to say what I'm thinking there, but okay. Got the ideas of what you're doing there. One last problem. Describe how the graph of each function compares with the graph of the parent function y equals log base b of x. First of all, I see describe. That means I'm looking for words. That fun little thing where you have to do words and math. Based on the original function, y equals log base b of x. Okay, we've been doing this all year. It's a theme. Have you noticed? What things do you see happening to this log graph? What do you see, Ross? Okay. When we multiply a number out front, that is a vertical stretch. And so I'll put it all in words here in a moment. I'm just going to label my equation. Someone else? What's another thing we see? What do you see, Dietrich? Okay. Remember, when the number is in the parentheses, it's left or right, opposite the sign. So since this is minus 3, we're going right 3. Last one. Up 4 because when the number is added or subtracted at the end, it's up or down with the sign. Okay? Those are the pieces you need to put them into words. So, vertical stretch by a factor of 2 and translated 3 units right and 4 units up. I didn't. I probably should have stated in the beginning that what graph were we doing this all to? The y equals log base b of x is vertically stretched by a factor of 2. Translate 3 units right and 4 units up. Okay, your homework is in Math Excel. Some of you have already started it, some of you not. It is due Monday. Make sure you get it done for Monday. And you have some work time now, so use it, please.